In this next question, we're being asked to solve for the variable x in the equation 4 over x squared minus 4 plus x minus 2 over x plus 2 equals 1. Well, what we're going to do for that is factor out the first denominator and factor the second denominator. And in doing that, we see the first denominator factors to x minus 2x plus 2, and the second denominator factors to simply x plus 2. Through doing this denominator work, we see that we have three factors, but only two distinct ones, x plus 2 and x minus 2. So we ask ourselves how many x minus 2 factors should be in our lowest common denominator. Well, in order to answer that question, we should ask how many x minus 2 factors are in our first denominator and how many are in our second. We have one x minus 2 factor in the first denominator and none in the second. We take the greater of those options and we have 1 in our lowest common denominator. We then look at the factor of x plus 2. We have 1 in the first denominator and 1 in the second denominator. So how many should we include? Well, the greater of those two options, or if they're the same, that's how many we take. So we'll take one factor of x plus 2 to be in our lowest common denominator. Now we state our restrictions at this point, and we see that x minus 2 cannot equal 0. Isolating x leads to the statement x cannot equal 2, and x plus 2 cannot equal 0. Isolating x leads to the statement x cannot equal negative 2. Now at this point, we look back at the original question and we tell ourselves x cannot equal 2 or negative 2. If by the end of the question we come to a solution of either x equaling 2 or x equaling negative 2, that solution will be invalid, because the idea of a restriction trumps the idea of it being a solution to the question. In other words, if I get to the end of the question and the answer is x equals 2, the answer is there is no solution, because x cannot equal 2. Okay, so moving on with the question then, we restate our first denominator as x minus 2, x plus 2, and we restate our second denominator as x minus 2, x plus 2, and our third denominator as x minus 2, x plus 2. And now we ask ourselves, what did we multiply x squared minus 4 by to get x minus 2, x plus 2? The answer is 1, so we multiply 4 by the same amount. Now we look here, x minus 2 over x plus 2. Well, what did we multiply x plus 2 by in the denominator to get this denominator of x minus 2, x plus 2? The answer is we multiplied it by x minus 2. So we're going to multiply this numerator by the same quantity. We'll have x minus 2, x minus 2. And finally, here we have a denominator of 1. So what did we multiply 1 by to get the new denominator of x minus 2, x plus 2? The answer is we multiplied it by x minus 2, x plus 2. So what are we going to multiply the original numerator of 1 by? The same thing, x minus 2 and x plus 2. And so that becomes our new numerator, x minus 2 and x plus 2. Now at this point we've considered our restrictions and we have gotten all our denominators to be the same. So we can, in slang, clear the denominators. What this actually means is that we're going to multiply each term by the denominator of x minus 2, x plus 2, which is a valid next step as long as we keep in mind the restrictions of x not equaling negative 2 or 2. That might sound confusing, but basically what this means is we've considered our restrictions, we've gotten all the denominators to be the same, now we're going to wipe them out and simply say 4 plus x minus 2, x minus 2 equals x minus 2, x plus 2, and then we're going to solve for x. And that's what we do. We just consider our numerators, 4 plus x minus 2, x plus 2, 4 plus x minus 2, x minus 2, equals x minus 2, x plus 2, equals x minus 2, x plus 2. And we go back to grade 10 and we solve this quadratic, where you need to expand it out, and then we need to eliminate the x squared terms. Notice that it starts out as a quadratic, but then the x squared terms are subtracted from each side, and we end up with 12 equaling 4x, or x equaling 3. Now we have to compare this answer to our restrictions. We have x equals 3, and we see if that's one of the invalid answers. The answer is no, it's not, so it is a valid answer. It's valid for x to equal 3. It simply can't equal 2 or negative 2. So since this solution does not conflict with the restriction, therefore x equals 3.